Hi everyone, so I think this is video number 5, I'm starting to lose track a little bit, where we're talking about the mechanism for our mass spec. So this time we're going to start looking at alcohols. Now alcohols have two types of fragmentation patterns. They can do alpha cleavage. Once again, that is our homolytic cleavage. Hopefully you checked out the videos on our alkyl chlorides and our ethers where we've gone through this, but the idea that we're moving one electron and using our single barbed or fishhook arrows to achieve this. The second type of cleavage for alcohols is dehydration or loss of water. So I'm going to have that in the next video for alcohols. For this one, we're just going to be looking at our alpha cleavage. Okay, so let's go ahead and get started. Now, this alcohol specifically is not symmetric, so I know I need to look for multiple different ways it can fragment with our alpha cleavage. Just like with that ether video, I'm going to start with the radical on the alcohol or the oxygen to get started. And just like with those ethers, we are going to begin the process of forming a double bond between the alpha carbon and the oxygen. We are going to finish that double bond by using one electron from the carbon-carbon bond. And then that other electron that was in this bond, we are going to put that on the carbon that is bonded to the alpha. So nothing has changed in terms of our arrows between the cleavage of ethers and alcohols with the alpha cleavage. So the first thing we're going to form is our methyl radical. And then we're going to have our cation species where that oxygen is positive. And then I'm going to have my carbon chain. Oh, I skipped a step. I was super focused on this in the previous video. We forgot to look at the molecular ion mass to charge ratio. So that would have been the mass of this entire thing. Let's look at this one since it doesn't have arrows drawn all over it. It's the same structure. So to calculate that, I'm going to have 16 from oxygen, and then I have 1, 2, 3, 4, 5. I have 6 carbons. That is going to be 72. Yep, 72 plus, okay, so I have 3, 6, 8, 10, 12, 13, and then 14 hydrogens here. So my mass to charge ratio of my molecular ion is going to be 16 plus 72 plus 14. I am getting a mass to charge ratio of 102. Hopefully that's right. Okay, so since this is the cation, I'm interested in the mass to charge ratio of this species. We can do the same thing we just did for the molecular ion where we go through and calculate that. I'm going to be lazy because I know I lost a methyl group. I can just say 102 minus 15, which is the molecular or the mass of the methyl. So 102 minus 15, and I'm getting 87 for this alpha cleavage. So that's the first fragment I would look for. Okay, so let's look at the other one. So again, the mass to charge ratio of my molecular ion peak is 102. So here we're going to do the same thing, but this time we're going to break the right side. So go ahead and hit pause and see what you come up with. All right, so let's start with that radical electron to begin the process of forming that double bond. I'll finish that double bond with one electron from the sigma, and then put the other electron from the sigma on that carbon connected to alpha. So my first fragment is going to be this species where I have my double bond and positive charge on oxygen. If you've been asking yourself, yes, they do still have a lone pair. I just don't have to draw them. And then the radical is going to be that butyl chain with that radical on the end. So here I'm interested in this species for my mass to charge ratio. Not going to lie, don't know this one off the top of my head like a methyl. So I'm going to go through that process of finding it the old-fashioned way. So I have 2 carbons, so that should be 24. I have an oxygen, and then I should have, let's see, I think 3, 4, 5 hydrogens. So plus 5, so 3, 4, yeah, I think we're good there. Oh, I don't want to do that because, all right. So my mass to charge ratio for this is going to be 24 plus 16 plus 5. Okay, I'm getting 45. All right, and then that's all the cleavage I can do here. So those are my 2 alpha cleavages. So mass to charge ratio of 45. All right, So I am going to go ahead and jump to the mass spec because I want to make sure I have that. All right, everything looking pretty good here. Okay, so I have my molecular ion peak at 102. I have my peak at 45. What was that other one that we had? 87. All right, and then I do see that 87. All right, so I'll talk about that again in the next video when I go through dehydration.